Let's take a look at congruent arcs and chords. So two chords are congruent if and only if the arcs they subtend are congruent. So let's take a look at the picture and see what that means. So two chords like A, B, and C, D are congruent if we know that the arcs, so like arc AHB is congruent to arc CID, for example, then we know that chord AB is congruent to chord CD. So if you know one of those are congruent, the other would also be congruent, like the chords or the arcs. We also know that two chords are congruent if they are equidistant from the center. So that means chord AB is equidistant from the center as chord CD, then we know they're congruent. And then in the next part of the notes, it says, if a diameter or a radius is perpendicular to a chord, so in the picture, they show the radius is perpendicular to the chords, both of them. And so that bisects the chord and its arc. So it would bisect AB and chord AB and arc AHB would both be bisected if that happens. And if it's perpendicular on this side, the same thing would happen. It bisects the chord or it bisects the arc. So that's just a lot to draw all at once. So I did it one at a time. And then I've written out all the things that it means. So if EF is perpendicular to AB, we know AF would be congruent to FB and AH would be congruent to HB. That's the bisected chord and the bisected arc. If EG is perpendicular to CD, then CG is congruent to GD, and CI, the arc, is congruent to arc ID. So let's take a look at some examples of these rules and work them out. So in number 1, it says find X, and we are given that these chords are congruent. So that tells us that the arcs, let me make that smaller. Let's see, the arcs that they subtend are also congruent. So we could just say 7x plus 24 equals 115. So if we subtract 24, let's see, we could just bring up our calculator to do a little math. Let's do 115 minus 24, and then divided by 7 would be our next step. So let's write that down. 7x equals 91, and then let's just divide by 7. So x would equal 13. All right, so that's it for that one, a nice simple one to start with. Number 2 says find xy. So that is labeled 4x plus 1. And what's also in the picture that's important are these 2 tick marks, because that means the chords would be congruent since the arcs are congruent. So they told us the arcs are congruent. Therefore, we know these chords that intercept or subtend the arc are also congruent. So I'm going to say 9x minus 34 is equal to 4x plus 1. And subtract 4x to put the x's on the same side. So I get 5x minus 34 equals 1. Then I'm going to add 34. So I get 5x equals 35 and divide by 5. And I get x equals 7, but it said to find xy. So I need to take this 7 and plug it back in. So 4 times 7 plus 1 would be xy, which is what I'm looking for. So that's 28 plus 1, which is 29. So that is it for example 2. Let's look at example 3. 3 says find x. So again, we're given some information, like we have these tick marks in the picture, which means the chords are congruent, and therefore we know that these arcs that they subtend are congruent, which will help us figure out what x is, because then we have enough information to add up all of these 3 parts of our circle, and we can set it equal to 360. So what I'm going to do is just do 2 times 6x minus 20, or you could just add them up, add up 2 of them. Plus 76 is equal to 360. So I get 12x when I distribute the 2 minus 40 plus 76 is equal to 360. So then I get 12x plus 36 equals 360. Let's subtract 36. So that would be 12x equals 324. And then let's divide that by 12. So we get 27. And then that's all we needed to do for this problem, was just find the x. So we're done with number 3. Let's take a look at number 4. If MP equals 5x minus 34 and PN equals 2x minus 4, find MP. So what we're given in this problem is that these these arcs are congruent, which tells us that the chords are congruent, and therefore we know these little pieces MP and PN, those segments are equidistant from the center, because we can kind of work backwards to see that that's true. And so I can set them equal to help me figure out my answer. So 5x minus 34 would equal 2x minus 4. I'm going to move 2x over, so I get 3x minus 34 equals negative 4. Let's add 34. So we get 3x equals 30, and then divide both sides by 3, so I get x equals 10, but that's not what it wanted. It wanted me to find MP, so I just need to plug it back in. Really, you could plug it back in either one of them because they're equal to each other, but I'm just going to do it in the one that said MP. So 5 times 10 minus 34 will be 50 minus 34, which would be 16. Okay. So that's it for number 4. We just have a few more examples. So if the measure of arc CI is 7x minus 15, let's write that down. That's 7x minus 15. And the measure of arc EF is 12x minus 8. So EF is 12x minus 8. Find the measure of arc CI. So notice these are labeled as equidistant from the center. And so therefore we can conclude that these arcs, like arc DC, would be congruent to arc EF. And so we need to multiply this one by 2 in order to set it equal to this side, because that's what we know. So 2 times 7x minus 15 would be equal to 12x minus 8. So I'm going to distribute the 2 and get 14x minus 30 equals 12x minus 8. And then I'm going to subtract 12x and get 2x minus 30 equals negative 8. And then I'm going to add 30. So I get 2x equals 22. And divide by 2, so I get x equals 11. But that's not what they wanted. They wanted me to find CI. And so that was 7x minus 15. So now I'm going to plug it back in. So arc CI is 7 times 11 minus 15. So 7 times 11 would be 77 minus 15 would equal 62. And it's the arc, so I'm going to put the little arc symbol there. That's it for number 5. Let's look at number 6. So this one says, in circle Z, if RS equals 18, okay, so let's highlight RS is 18, and measure of arc TY is 42, find each measure. So TV, we got to label a few more things. So they've told us these are equidistant from the center, which means that these arcs and chords would be congruent and bisected. So that's lots of information we know. These chords are congruent and they are also bisected. And I made a mistake on RS. I need to back up. RS is not the arc. They gave me, like, notice there's no arc symbol right there. So RS is 18, means this is 9 for RW. And this would be 9 for WS. So I put that in the wrong spot. I fixed it. Okay, so TV would also be 9 because those are equal to the ones on the other chord. So that would just be 9. And then TU would be 18 because we could add those up. WS would be 9. And then they want arc YU. So YU would be equal, like these are equal right here. So that would also be 42 degrees. And then they want arc RS. So RS, the arc, would be equal to the 42 plus the 42 because it's equal to the ones that are on this side, but we just have to add it up. So that would be 84 degrees. All right, I think we have another one down here. 2 more questions. So this example says find VW. And above there in your notes, it has a reminder about sine, cosine, and tangent and how we can use those to figure out missing sides or angles. So we need to find VW, the chord right there. And we know that this right triangle has a side of 5 and 13. So we could find the third side just using Pythagorean theorem. So I'm going to do 13 squared minus 5 squared equals that missing side squared. So that would be 169 minus 25, which is 144. So that side, when we take the square root, would just be 12. Okay, so VW would be 12, and then we notice that that's a right angle. So that means that this chord was bisected. Because of that right angle, we know that's true. So that's 12 for VZ, and ZW is 12. So VW would equal 24. Then it says find the measure of arc YW. And so we need to know the central angle for that one. Let me grab another color. So like, let's see. The central angle is right there, and that would equal the measure of this arc. So what we're going to do is use trig to help us figure out that missing angle. So if you look at that little angle, we could use sine, cosine, or tangent. It doesn't really matter. I'm just going to use sine. So sine of that angle we're looking for, which is right there, is going to be opposite of it, which is 12 over the hypotenuse, which is 13. And then we just have to take the inverse sine to figure out the missing angle and type that in the calculator. So if I do second sine and then 12 divided by 13, I get about 67.4. Let me make sure I'm in degree mode. I am. So let's round to like 67, the nearest degree. And that would equal the arc YW because the central angle equals the intercepted arc. And I believe that